Okay, let's dive right into this explainer. Today, we're unpacking a really fascinating new architecture that could literally rewire how we organize and pull up digital information. We're looking at a system that challenges the very foundation of how we navigate data, moving us far beyond the traditional flat links we've relied on for decades.
Here is our agenda for today. 1. The internet we know. 2. A new architecture. 3. How fractal grids actually work. 4. The patent allowance. And 5. Future real-world applications.
Section 1. The internet we know.
We're on the web every single day, right? We barely even think about it. But it really begs a massive question about the future of digital organization. What comes after the World Wide Web? Are we just kind of stuck with standard pages and links forever? Or is there a completely different architectural layer waiting to be unlocked?
To figure out where we're going, we've got to remember how we got here in the first place. Tim Berners-Lee revolutionized our world by asking, how can documents anywhere in the world be linked together? His solution gave us an internet of globally linkable pages all riding on a flat hyperlink graph. And honestly, it was an absolutely brilliant fix for connecting isolated documents across the globe. Section 2. A new architecture.
As our digital world exploded, information got incredibly fragmented and hard to retrieve. This comparison perfectly illustrates the complementary difference between two distinct approaches. Berners-Lee connected documents using URL navigation over a flat graph. On the flip side, inventor Rodney King proposes a concept-centric, hierarchical, recursive geometry. Instead of flipping through flat pages, you're using cell navigation to organize knowledge itself. It's like zooming into a map where every single city holds another entire world inside it. They don't compete, they are completely complementary.
You can really see how this shift maps out our digital paradigm. Web 1.0 was all about documents. Web 2.0 brought in the people. Web 3 is focused on assets. While the traditional web changed where information lives, this potential evolution into structured recursive knowledge spaces could fundamentally change how we think with information. It's a hypothetical leap from an internet of pages directly to an internet of structured knowledge objects.
Section 3. How fractal grids work. So what is the actual mechanism here? It all comes down to a recursive information architecture. Look, the current web has no inherent geometry. It's just a massive tangled graph. But with this, instead of just clicking a flat link to load a new page, imagine physically zooming into conceptual spaces, where information is organized and navigated geometrically.
Watch how this builds logically. You don't just jump sideways to a new URL. You start at a top-level grid. You zoom into a specific cell, and boom, that cell recursively expands into a brand new grid entirely, which has its own cells, and so on. You're navigating recursively among structured information cells linked by their physical position and hierarchy.
And what happens inside those geometric spaces is absolutely crucial. These cells aren't just empty folders. They contain data on opposite sides, acting exactly like a digital flashcard. According to this architecture, you can maintain multiple representations of data within one single cell and instantly retrieve them based on their exact physical position in that grid.
Section 4. The patent allowance. Now, to prove this isn't just some abstract theory, let's look at the official legal framework. Here, we have the official notice of allowance from the United States Patent and Trademark Office, issued to the lead inventor, Rodney King, in June 2026. This officially confirms the patentability of storing and accessing data using multilevel fractal grids. And what's incredibly cool about this is King's broader vision. Being from Sierra Leone, he actively desires to use this newly approved technology to facilitate major development right back in Sierra Leone.
And if you check out the examiner's explicit reasoning in the paperwork, you'll see exactly why this got approved. The examiner points out that prior art simply did not teach this combination. Past inventions completely failed to combine a recursive fractal grid structure with common cell identifiers and two-sided editor arrays. It's this exact geometric, flashcard-like storage methodology that sets it entirely apart.
Section 5. Future real-world applications.
The potential to facilitate global development here is absolutely massive. We are looking at a foundational technology where you could design so many different projects to rapidly generate multi-millions, honestly if not billions, of dollars in market value. Just think about giving AI systems explainable structured memory, or picture a doctor instantly navigating complex clinical decision trees to save a life. From interactive educational textbooks to huge enterprise strategic planning and scientific knowledge synthesis, the commercial applications are staggering.
But we have to be realistic here. A patent alone doesn't instantly transform the internet. Just like HTML and web browsers were required to make the web mainstream, this patented storage method is going to need a robust ecosystem. We're talking developer tools, open standards, and broad market adoption. The engineering execution has to step up and match this architectural vision for it to achieve true internet-scale impact.
As we close out this explainer, I want to leave you with a really provocative thought. If we successfully transition from navigating a flat network of documents to exploring deeply recursive, structured knowledge spaces, how will that permanently alter human cognition? Are we literally on the verge of moving from an internet of pages to an internet of thought? It is a wild concept to consider, and I really hope this provided a clear window into what that future might just look like.